In this video, I'll go over the basics of XY data, some examples, and how MyAssays can be used to perform your XY data analysis. The term XY data refers to measurements that are collected across multiple time points or wavelengths. This includes kinetic and spectral data. Kinetic data can be fast or slow. Fast kinetics is where all cycles are measured in one well before the next well is read. This is appropriate in cases where the reaction occurs very quickly. Slow kinetic assays read the entire plate once before returning for a second read. Regardless of whether the kinetics assay is slow or fast, the data analysis process is the same. I have open a kinetics protocol. The tabs on the left-hand side of the screen will allow you to import your measurement data, specify your plate layout, and enter your sample IDs. On the Measurements tab, you can see the raw data in a pad format and the thumb plot to the right. The Plate tab will show the thumb plots, and on the Chart tab, we can view the data by sample group or by sample position. The chart view will also allow you to optionally select and remove outliers by left-clicking on the point you'd like to remove. This flags the point, and it will be excluded from additional analysis. Once you've flagged a sample, a Flags button will appear and allow you to view the currently flagged samples and optionally re-include them. The Meta tab will show any associated metadata, and the Plate IDs tab will allow us to add a plate ID. The Microplate tab will allow us to select our plate layout. We can choose from the available layouts, edit an existing layout, or create our own. By clicking the Sample Types button at the bottom right of the screen, we can manage the sample types included in our assay. Finally, by using the Sample IDs tab, we can manually type in the sample IDs, copy and paste the information, or use the import wizard. You'll notice the visual feedback in the pane on the right-hand side of the screen. The wells that contain the data associated with the currently selected sample flash. Let's calculate our data. In our report, we can see a sample table containing the sample IDs, their positions, and a thumb plot of the raw data. In the Properties tab, we can specify our assay settings and add transforms to perform data analysis. On the Transforms tab, by clicking Add, we can view all applicable XY transforms. By clicking on a transform, we can view the description, properties, and an example. I'll click Create and add the XY reduction peak transform. Now we can specify the associated settings. In all XY transforms, we can select which data should be plotted on the x-axis and which data should be plotted on the y-axis. We can specify minimum and maximum values for range, define whether the peak should be reported at the maximum or the minimum, and whether we want to report the result at x or y. We can also specify the output units. Let's recalculate. Now on our report, we can see the addition of the peak column to the sample table, as well as the addition of the XY reduction peak tab. By viewing this tab, we can see an interactive chart where we can set limits and again remove any outliers. On position A1, I can easily see that we appear to have a contamination issue with 3 of our time points. I'll left-click these points and exclude them from analysis. I can again click on the Flags button and see the 3 points that I've removed. Let's recalculate once more to see our data with those outliers removed. Now on our report, we can see that the outliers have been removed, and on position A1, the peak now reports the maximum of the uncontaminated data points. For more information about working with XY data, please see the subsequent videos in this series. If you have any questions, please email us at support@myassays.com.